Okay, my dear students. So today we will start second order partial differential equations. Okay, so we will be focusing on homogeneous, linear, partial differential equations with constant coefficients. And as I mentioned that we will be focusing on second order. So I will be discussing the I will be discussing one type in this video and one more type I will discuss in the next one. So let us directly start with a question. Question is solve. Let us take a second order partial differential equation which is homogeneous, which is linear and has constant coefficients. Let us say d square, where d represents dou by dou x, partial derivative with respect to x, plus 4d d prime, where d prime represents dou by dou y, partial derivative with respect to y, minus 5 times d prime square bracket. Then we have our dependent variable z is equal to e to the power 2x minus 3y. Okay, let us see the solution, how we solve this partial differential equation of second order. Now, as many things will sound similar to what we did when we were solving second order ordinary differential equations. If you remember, in ODE, we started with auxiliary equation. Same way, we will start here also with the auxiliary equation. Now, auxiliary equation we will find using this part which is inside the bracket. What we will do? We will put d is equal to m and we will put d prime is equal to 1. So what happens? So this part which is inside the bracket will give me m square plus 4 times m times 1, that will be 4m, minus 5 times 1 square, that will be 1. So I am getting m square plus 4m minus 5, and this we will put as equal to 0. So I have a quadratic equation. I will solve for m. So simple factorization will give you two values of m, that will be minus 5 and 1. Okay. Now, using these two values, we will write our complementary function. Same language we used in second order ODE also. So we will directly write this implies our complementary function. In short, I am writing it as CF. You can denote it by ZC also. That is also fine. So ZC, now how to write the complementary function? F1, some function F1 of y first value of m which you have got, y minus 5 times x. Let's go to the second one, plus some other function f2. Now what will be the term? Function of y, then the second value, that is 1, plus 1 times x. What is the formula? How we have done this? Actually, whenever you are getting two values, two distinct values of m, two distinct real values, okay? If you are getting distinct values which are real, okay? So what is the form of the complementary function? This will be some constant f1 of y plus m1 x, which is the first value of m, plus some other function f2 of y plus m2x, which is the second value of m. So this is actually the, you can call it as a rule also. So you have obtained the complementary function. So one part of the question is done, where we calculate the complementary function. So this is done. So your complementary function ZC is equal to f1 of y minus 5x plus f2 of y plus x. Okay, this is done. Now second part. Same language as we used while we were solving ordinary differential equations. What we used to find? After finding the complementary function, we used to find the particular integral. So this you can denote as pi. Okay. So now we are finding the particular integral. You can call it as zp. And to find zp, to find the particular integral, we will use the function which we have on the right side, the function of x and y, which is present on the right hand side of the partial differential equation. So our steps will be dependent on what is the right side of the function. What is the function at the right side of the equation? So our steps will depend on what this function is. Now here we have an exponential function, e to the power 2x minus 3y. So in this case, how to find the particular integral? Now, particular integral will be 1 over d square plus 4 d d prime minus 5 d prime square operating on e to the power 2x minus 3y. Or in simple language, you can say that what we have done, we have just shifted this part to the right side, isn't it? So we are trying to find this z by shifting our whatever we had inside this bracket to the right side, isn't it? So it becomes 1 over, so z will be equal to 1 over d square plus 4d d prime minus 5d prime square operating on the right side, that is e power 2x minus 3y. Okay, so that value of z actually will be the particular integral, the zp. Okay, now how to move ahead? What shall we do now? Now I will write the technique here. Now the technique to be used when you have this right side in this form, right? E to the power 2x minus 3y. So actually your right side is in the form of e to the power some constant ax plus some constant by. In this case, what we do, we just replace d by a and we just replace d prime by b. That's all. This is our technique to solve this zp. Let us continue. So what shall we do here? A will be equal to 2 here, right? And b here it is minus 3. So this 2 will be equal to d. So I will replace my d by 2. And this b, that is minus 3, will be equal to my d prime. So d prime I will replace by minus 3. That's all. This is the simple technique to find the particular integral, this particular integral. Okay, when you have e to the power ax plus b type, ax plus by type of a function on the right side. Okay, so what we get? 1 over d square. D is equal to 2. So d square will be 4, right? Plus 4 times d, that is 2, multiplied by d prime, that is minus 3, minus 5 times d prime square. So d prime is minus 3. So minus 3 whole square, that will be 9. Operating on e to the power 2x minus 3y. And what we get here, that will be 1 over negative 65 e to the power 2x minus 3y. That's all. You are ready to write the solution. What will be the solution now? Therefore, the general solution, you can also call it as a complete solution. This will be equal to, you can call it as z. Okay, the general solution z, this will be equal to zc plus zp. That's all. What is our zc? Our zc is equal to f1 y minus 5x plus f2 y plus x This is our ZC plus ZP, which you have evaluated just now. That is minus 1 over 65 e to the power 2x minus 3y. So this is your general solution, or you can also call it as a complete solution also. So this is our first type of second order partial differential equation which I wanted to discuss. And in the next video, I will be discussing another type where we will change the right hand side of the partial differential equation. We will take some other function and we will discuss that type in the next video. Okay, so that's all for this one. We will see in the next video. Take care, all of you.